let's look at one more example here that's a little bit more challenging. So this one says that we have an equilateral triangle that has a perimeter of 21 meters. It says if the area is multiplied by 1/2, what happens to its side length? Okay. Okay. So let's look at this instead of I'm just going to pretend for a second like we don't know this. This 21 meters, and we're just going to treat this like a problem with just a random equilateral triangle. Okay, so I'm just going to grab this, I'll move it over here. All right, my pen here. What I'm going to do is I'm just going to try to come up with some random formula so we can find the height of this equilateral triangle. Right, so we know that all these sides have the same measure. We're just going to call this side length S. Okay, I know my 5s look like S's, but we're just going to call this side length S. Okay, and what I'm going to do is I'm just going to bisect this angle right here. And this is just an altitude that represents the height, right? So we know that this is a 90-degree angle. Okay, if this is an equilateral triangle, we know that each vertex has an angle of 30 degrees, and that would mean that half of that, each vertex has an angle of 60 degrees, half of that would be 30 degrees, right? And so we know that this angle right here is just going to be 30 degrees. Okay, well, if we know our special right triangles, okay, and I know that some of you do, some of you don't, okay, but if we say, well, if this is 30 degrees, okay, the side opposite of the 30 degrees, we can call this x, right, or you can call it 1, right, but in this case, the side opposite of the 30 degrees is going to be x, okay, and then whatever this side length is, okay, the side opposite of the 60-degree angle is going to be x radical 3, okay, and then our hypotenuse is going to be 2 times x. Right, and so again, this is why it's part of why it's important to memorize your special right triangles. Okay, and so now what we're going to do is sort of develop this little formula for area of this particular triangle. Right, so the area is going to be equal to 1/2 times base times height. Okay, well the area then would be equal to 1/2 times our base, which is s, times our height, which we don't really know yet. Okay, so what I'm going to do is I'm going to go kind of off over here, and I'm just going to say that the cosine of 30 degrees is going to give us an expression for the height. So the cosine of 30 degrees in this case is going to be the adjacent, right? Let me put this in a adjacent right here over the hypotenuse, which is here. Okay, and so what I'm going to find here is that the cosine of 30 degrees is the adjacent is x times radical 3 over the hypotenuse here, which is 2 times x. Okay, well the x over x will cancel here. So an expression that represents the height or the height of this triangle is just going to be radical 3 over 2 multiplied by whatever our side length is. Okay, and so I'm going to write this here as radical 3 over 2 times s. Sorry about that. So radical 3 over 2 times s. Okay, is going to represent our height. Okay, and so at this point, what I'm going to do is just simplify this here a little bit, and what we would actually get is that our area is going to be equal to 1 times radical 3 is going to be radical 3. Okay, 2 times 2 will give us 4, and the s times s will give us s squared. Okay, and so this is a nice little expression here that sort of represents, I guess, our area, okay, of this particular triangle. Okay, and so now what I'm going to do is kind of shift gears for a second here and take a look at what this triangle is probably actually like, right? So it says it's an equilateral triangle. Okay, it says it has a side length of 7, right? Well, its perimeter is 7, so we know its side lengths each have to be 7, right? Because they're all the same, because 21 divided by 3 equals 7, okay? And so from here, what we're actually going to do is just sort of kind of write out the formula that we have, right? So we know that we're going to use this red formula, and I'm just going to write down that the area of this triangle is going to be equal to radical 3 over 4 multiplied by whatever our side length is, which is 7, and then we square that, right? And so that would mean that our area is going to be equal to 49 times radical 3 over 4. Okay? So good. Like we now know, I guess, an expression for the area of the triangle that they originally gave us. Okay, so that's good. Okay, now what we're really concerned with now is it says the area is actually multiplied by 1/2. Okay, and so we have to take our area that we have here, and it's multiplied by 1/2, right? So our new area is going to be, I guess it would be 49 times radical 3 over 8. Okay, so our new triangle is going to look like this. Okay, so now what I have to do is I'm going to try to figure out, okay, what actually happened to our side length. Okay, and so I have to look at this part here, which just represents kind of a formula for some arbitrary value of s, right? We don't know what s actually is. We don't know what the side length is, if it's 5 or whether it's 100. Okay, this is just a formula that we can use for any side length. Okay, and now we have a formula for some specific side length. Okay, so all I'm going to do is I'm going to take this part of the formula and I'm going to substitute it right here for a. Okay, and so I'll rewrite this. I'm just going to say now that radical 3 over 4 times the side length squared is going to be equal to 49 times radical 3 over 8. Okay, and now I'm trying to isolate for s squared. That's what I want to get by itself, right? I want to get this part alone. Okay, so I need to multiply by the reciprocal on both sides here. Okay, so if I multiply both sides by the reciprocal, I'll multiply both sides by 4 over radical 3, right? So I'll multiply this by 4 over radical 3. Okay, and the reciprocals will multiply to 1, so I can just kind of cross those out. I can do some more reducing over here. Rad 3 over rad 3 will cross cancel, and I know that 4 over 8 will reduce to 1 over 2. Okay, so I'll do this part, I'll call this 1 over 2. All right, so what I have left over now is that my side squared is going to be equal to 49 over 2. Okay, and now what I have to do is isolate for s, or isolate for my side length. And so what I'm going to do now is I'll take the square root of both sides. So remember that s is going to be equal to the quotient property of radicals is going to tell us that we can do this. Okay, and so basically s is going to be equal to 7 over radical 2. Okay, well remember, we can't keep a radical in the denominator, so we multiply both the top and the bottom by radical 2. Okay, and we find that our side length is now going to be equal to 7 times radical 2 over 2. Okay, and so this is our new side length, okay, of our new triangle that they asked about. Okay, and they said, what happens to the side length? Okay, well remember, originally, okay, we'll say originally the side length equals 7, right? Now, s is 7 rad 2 over 2, right? So basically we can say that s was multiplied by radical 2 over 2. Okay, so this is an example of a problem that's a little bit more complicated, okay, and we really need to have a lot of knowledge of special right triangles to make it work.